The Security Plus exam is going to be testing you on securing items that exist not only on premises, but also cloud configurations. So before we can secure a cloud computing environment, we first have to have a sense of cloud deployment models. What does that mean? Well, we're going to define what it means. First of all, cloud computing. It's a buzz phrase everyone hears about all the time, but what is it really? All it really means is we are running IT services on somebody else's equipment over a network. Really, in a simplified way, that would be a correct way to state what cloud computing is about. However, on the client side, to access cloud services, we might only need a web browser, or in some cases, we might need to install an extension in a browser or a full-fledged app, a thick client, so to speak, to access a particular cloud service. As you might guess, there are all kinds of cloud services available out there. You probably use a lot of them. If you've ever used Hotmail, Gmail, Yahoo Mail, Facebook, Twitter, those are cloud services because they're not running on your equipment. They're running somewhere else on some equipment in a data center, and you're accessing them over a network. Believe it or not, that's an example of cloud computing. Now, there's also this concept of fog or edge computing. The idea is that, let's say an enterprise is storing files in the cloud. Okay, fair enough. However, there is an option where we could have an on-premises device, an on-premises server that caches cloud-stored content on that device. The benefit being that for on-premises users on your network, they have local access to that content, which presumably is going to be much quicker than accessing it over the internet where it's stored in the cloud. So the on-premises storage of those cached files will be synchronized with the cloud, and that on-premises device is called a fog or edge computing device. In our diagram, we have an on-premises network that can be linked to the public cloud. Now, how can that happen? Well, through any kind of internet connection, but what protocols would be used? Usually HTTPS, so it's secured, but you can also set up a site-to-site VPN from your on-premises network directly into your cloud account. We talked about site-to-site VPNs already. The benefit here is after I've established the VPN tunnel into the cloud, I can refer to cloud resources like virtual machines by using their private IP addresses, because when I VPN into a remote network, it's like I'm there. So I don't need to access public IP addresses or anything like that. I am on that remote network, at least conceptually. So in the cloud, we might access services like network security tools, storage in the cloud, software developer tools, virtual machines, databases, machine learning tools, and a whole host of other services too numerous to mention here. Now, there is a common misconception that if you have virtual machines, that's cloud computing. It is not. In order to have a cloud, we have to satisfy a number of conditions. So cloud computing characteristics include pooled resources. That means having a number of underlying physical servers that can run virtual machines, maybe a bunch of storage arrays that can be provisioned by users, that type of thing. The next characteristic is broad access. All that means is you access it over a network from any type of device. The next characteristic, self-service provisioning. And this is a cool thing about cloud computing. You don't have to issue a help desk ticket or a request to say, hey, could you spin up this Linux VM for me? You do it yourself because it's so incredibly easy, whether it's in a GUI or at the command line. Rapid elasticity. This means that pretty much with the click of a mouse, at a moment's notice, we can decide, I'd like another 250 gigabytes of storage, or I'd like to spin up 10 Windows virtual machines. Rapid elasticity. You can provision or deprovision cloud services as you see fit very, very rapidly. The next characteristic is metered usage. What happens in a cloud environment is your usage of cloud services is tracked. So think of a virtual machine, say, that you deploy in the cloud. For every minute that it's running, you're paying a fee. So if you leave that running all the time when it doesn't need to be, because maybe it's a test virtual machine, you are unnecessarily incurring charges. So metered usage is kind of like a utility, like power or water. The more you use, the more you pay. But the cool thing is that you're not paying the upfront capital investment for the equipment, because remember, with cloud computing, it's running on someone else's equipment over the network. One cloud deployment model is a public cloud that comes in the form of things like Alibaba Cloud or Amazon Web Services or the Microsoft Azure Cloud. It's public, which means it's available over the internet and anybody potentially could sign up for an account in that provider. That means that we have cloud tenant isolation. A cloud tenant is simply a cloud customer. So if I am a customer of Amazon Web Services and you are, I'm not worried that you can get into my data or that you can sign in with my account. They're completely isolated environments. Now in the cloud, because of metered usage, you're paying for what you use. That's considered to be an ongoing monthly expense, or OPEX, operating expense. But there is a shared responsibility between the cloud service provider and you. For example, if you want to deploy a virtual machine in the public cloud, you are not responsible for the hardware that makes that happen. The cloud provider is. They need to make sure they have enough storage and network configurations and a hypervisor to launch your VM. You're just responsible for configuring the VM and applying patches to it. So that's shared responsibility in the cloud. Now, another cloud deployment model is a private cloud. It still meets all the characteristics we talked about a few minutes ago, but the difference is that it's only used by a single organization, not anybody over the internet, which is a public cloud. So the cloud then, in this case, is owned and used by one company, and it requires an upfront capital investment, otherwise called CapEx. Because if it's your equipment, you have to have that equipment. You have to order it, you have to pay for it, you have to maintain it, but you have way more configuration flexibility than you would in the public cloud because it's your equipment and you have direct access to it. So the organization that owns the public cloud would assume full responsibility for every aspect of that cloud, but it is limited to be used only by that organization. We have hybrid clouds, as you might guess, that would combine things like a public and a private cloud at the same time. An example of that might be if you have an on-premises private cloud running mission-critical virtual machines, but for redundancy purposes, you replicate them into the public cloud just as a safety net. You're using private and public, that's a hybrid cloud configuration. And the final cloud deployment model is a community cloud. This is a specialized type of cloud that really services customers that have very specific requirements, similar requirements. So imagine that US government agencies have very strict security requirements on how they use cloud computing, and they do. So therefore, we would need a special community cloud to service those US government agencies. And as a matter of fact, there is a government cloud in Microsoft Azure, for example. It's called Government Cloud. There's also a German cloud that adheres to the requirements for German agencies and organizations. So you might also have clouds that are specialized to certain industries, like the medical industry or the financial industry. All it means is that we have tenants that have the same types of cloud computing requirements. So in the Security Plus exam, you might be presented with a question where they indirectly test your knowledge of cloud deployment models. You won't ever get a question that says, what's a public cloud? That's too direct and easy, but it might be embedded within a scenario. So make sure you read the questions carefully to see if that's what you're being asked for.